Force is an external agent which tends to change a body at rest to motion or a body in motion to rest. It is a push or pull upon an object resulting from the object's interaction with another object. This would be the definition of force taught in science classes during our elementary school days. It can explain why planets are revolving around the sun, how atoms interact and forms a molecule, why so much energy is created from an atom bomb, which is able to destroy a whole city in a country within few minutes. What is the reason behind the energy from sun? Now let us discuss about the force, which are of four forms basically. That is the four fundamental forces in nature. The reason why the forces are called fundamental because they are responsible for all observations in nature. And also note that any other forces like frictional force, tensile force, spring force, other than these four forces are another form of these four forces. The fundamental force in nature is also called as fundamental interactions. The types of fundamental forces are gravitational force, electromagnetic force, strong nuclear force, and weak nuclear force. Gravitational force. It acts between any objects which have mass. This force acts between planets, stars, and galaxies. This force is responsible for the large-scale phenomena of the universe such as formation and evolution of stars, galaxies, and galactic clusters. Now let us discuss about the properties of gravitational force. It is always attractive in nature. There is no repulsion in this case. It obeys inverse square law. The next property is charge independency. This force acts between any bodies, irrespective of whether they are positively charged or negatively charged. It is a long-range force. We know that the force acting between galaxies, stars, and planets. And its strength is weak. It is the weakest force among all the three forces. The carrier particle of gravitational field is called as graviton. Electromagnetic force. It acts between any charged bodies. It consists of two components, one is electric and another one is magnetic, which are inseparable. It governs all the chemical reactions. It is responsible for phenomena such as elasticity, friction, normal force, etc. Electromagnetic force is either attractive or repulsive. If the force acting between any two bodies are of same charged particles, say either positively charged or negatively charged, then the force acting between them is repulsive. Suppose the force acting between the bodies are of differently charged particles, say one is of positively charged and another one is of negatively charged, then the force acting between them is attractive. It also obeys inverse square law, and this force is charge dependent. It is also a long-range force. Its strength is weaker than strong nuclear force, but its strength is stronger than gravitational and weak nuclear force. The carrier particle of electromagnetic field is photon. Strong nuclear force. It binds protons and neutrons in the nucleus. Protons in the nucleus repel one another as they are positively charged particles. But strong force exist in the nucleus can overcome this repulsion, so the particles stay bound in an atomic nucleus. Thus, formation of an atomic nuclei is possible due to strong nuclear force. Strong nuclear force is strong attractive force. It does not obey inverse square law. It is charge independent. It is a short range force. It acts in the nuclear range. Its strength is very strong. It is the strongest among all other three forces. The carrier particle of strong nuclear field is pi meson. Weak nuclear force. It appears only in certain nuclear processes, such as the beta decay of a nucleus and particle decay. It governs the decay of unstable particles, such as mesons, and initiates the nuclear fusion reaction occurring in Sun. Weak nuclear force is neither attractive nor repulsive. It does not obey inverse square law. It is charge independent. It is a short range force. It acts in the nuclear range alone. Its strength is weak, but not so weak as gravitational force. The carrier particles of weak nuclear field are W and Z bosons. Many atoms have been made by physics people to unify the fundamental forces. At first, Newton unified terrestrial and celestial domains under a common law of gravitation. The experimental discoveries of Ørsted and Faraday showed that electric and magnetic phenomena are in general inseparable. Maxwell unified electromagnetism and optics with the discovery that light is an electromagnetic wave. Einstein attempted to unify gravity and electromagnetism but could not succeed in this venture. Sheldon Glashow, Abdul Salam, and Steven Weinberg got success in combining weak nuclear force and electromagnetic force into a single electro-weak force theoretically. Later it was verified by Carlo Rubbia and Simon van der Meer. Thanks for watching. If you like our videos, share it, subscribe our channel and enable the bell icon for future video notifications.